My guest today is Dr. Sophie Richards, a biochemist who specializes in hematology, the study of blood. She's here to update us on an amazing discovery. Dr. Richards, before we get into what's new in your field, can you explain a bit about what blood groups are?
Sure. Well, even though everyone's blood is comprised of the same basic components, we don't all have the same blood type because of special markers called antigens. Some people have A antigens, others have B antigens, and some have both A and B antigens. But there are those who have neither A nor B antigens. That's type O blood.
That explains where type A, B, and O come from, but aren't there also positives and negatives in blood types, like A positive or B negative and so on?
Yes. Each of those four main blood groups can either be positive or negative, so there are a total of 8 common possibilities for an individual's blood group. Not all blood groups are compatible, however, so they often can't donate to each other. Type O is different, though, because it doesn't have A or B antigens. People with type O blood are called universal donors because they can donate blood to anyone.
And that's what you're going to talk to us about today, isn't it? An exciting new discovery that has major implications for emergency departments and labs that manage blood banks.
That's right. A team of researchers at a leading Canadian university have recently discovered enzymes in our gut that may be capable of converting other blood types to type O blood.
Very interesting. How did they make that discovery?
Well, they used a special technique that allowed them to extract the DNA of microbes in the human gut. They focused on bacteria that feed on sugars by producing an enzyme, because the antigens of the blood groups are sugars.
So they were specifically looking for enzymes that could break down A and B antigens and get rid of them?
Right. Because, as we mentioned earlier, type O blood doesn't have these antigens. The scientists found that these gut enzymes are actually 30 times more efficient at removing the A and B antigens than any of the other enzymes previously studied. That's a major breakthrough.
Remarkable.
Of course, more testing is needed to determine whether the technique is a sustainable and efficient one. But things look promising so far. And if this technique works, we can modify any blood donation with these enzymes and finally have a dependable source of blood to use in emergencies.
All very interesting stuff, Dr. Richards. Thanks for sharing.